What is back pressure? Back pressure is a flow control mechanism used in data processing systems to prevent overwhelming a system with too much data at once. It is especially relevant in asynchronous and stream processing systems where data flows through a series of stages or components. Back pressure helps maintain system stability and ensures that each component processes data at the manageable rate. Let's talk about some key aspects of back pressure. And the first thing that we'd like to talk about will be the flow control. So, the flow control, back pressure controls the rate of data flow between producers and consumers. If a consumer is slower than the producer, back pressure signals the producer to slow down or stop sending more data until the consumer catches up. The second thing, we have buffer management. So, buffers are used to temporarily store data between stages. When these buffers become full, back pressure mechanisms trigger to prevent additional data from being added, thereby avoiding buffer overflows and potential data loss. Number three, we have data sources and sinks. Sorry. So, in systems like messaging queues, databases, or network protocols, back pressure ensures that data sources, which are the producer, do not overwhelm the data sinks, which are the consumers. Let's talk about how back pressure works. So, first, we want to talk about signaling mechanism. So, when a consumer is unable to keep up with the incoming data, it sends a signal upstream to the producer. This signal can be explicit, so acknowledgement message, or implicit, which is slowing down the rate of data reading. And number two, we have throttling. So upon receiving data, upon receiving the back pressure signal, the producer throttles the rate of data production, either by slowing down or pausing data generation until the consumer is ready to process more data. And number three, buffer saturation. So back pressure mechanism monitor buffer saturation levels. When buffers approach their capacity, back pressure signals are triggered to prevent additional data from entering the buffer until space is available. So let's talk about some examples of, of back pressures. The first thing, which is reactive streams. So in reactive programming, back pressure is core concept. Libraries and frameworks like Reactive X and Project Refactor provide built-in pressure support to handle data flow efficiently. Number two, network protocols. So TCP and IP uses back pressure mechanisms like sliding windows to manage the flow of data between sender and receiver, ensuring that the sender does not overwhelm the receiver. And number three, message queues. So message brokers like Apache Kafka and RabbitMQ use back pressure to control the rate at which messages are produced and consumed, preventing consumers from being overwhelmed. So let's talk about the benefits of back pressure. The first thing, which will be the system stability. So prevent system crashes and failure by managing the load and ensure that components operate within their capacity. Number two, efficient resource utilization. So optimizes the use of system resources like memory and CPU by controlling the flow of data and avoiding bottlenecks. Number three, improved performance. So maintenance a balanced data flow, which can lead to more predictable and consistent consumer across the system. And number four, we have error preventing. So reduces the risk of data loss, buffer overwhelms, and other errors associated with high data throughput. So, in conclusion, back pressure is a crucial mechanism in modern data processing systems, enabling efficient and reliable flow control. By implementing back pressure, systems can handle varying loads gracefully, prevent resource exhaustion, and ensure smooth and stable operations. So, that's it for this video, and see you in the future.